Hi all, welcome to online learning. I know we started 6.2D, that's my daughter at least, in Desmos, but not everyone has a touchscreen. So we're gonna go ahead and do it PDF style. So here we go. On the coordinate plane, find the distance between point A and C and the distance between point C and B. Well, these are pretty easy because AC is vertical, so I can just count the units, 1, 2, 3, and BC is horizontal, so I can count those units too. 1, 2, 3, 4, 5, 6, 7. So when they're vertical and horizontal, easy peasy, I can just count. AC is 3 and BC was 7. I could also look at the coordinates. So when I had AC, the -2s and -2s were the same. So I was just really looking at the difference between the 6 and the 3, which is a distance of 3. And then when I was looking at the horizontal, the 3's are the same. So I was looking at the -2 and the 5, and -2 is 7 away from 5. So I can look at the coordinates or I can count on the grid. Number 2, create a triangle and explain with words how you can determine the actual distance. Well, what did we just learn about a triangle? We learned that the short leg squared plus the medium leg squared is equal to the hypotenuse squared. So here, I would be able to use Pythagorean theorem. Okay, so 3 squared plus 7 squared equals the hypotenuse squared. 3 squared is 9, and 7 squared is 49. Together, that gives me 58 equals hypotenuse squared. So I'm taking the square root of 58 to get the hypotenuse. And then I need to think, is the square root of 58 simplified or not? So I think 2 times 29, 29 is prime, so I'm simplified. So I can leave it like that. Sometimes they'll ask you to round, then I would just stick it in my calculator and say, hey, that is about 7.6. Now I know the hypotenuse should be the longest side, and 7.6 is definitely longer than 3 or 7, so at least I know I'm not crazy. Okay, so we did a numerical example, and now we want to do it with our variables. So here, I want to know what the coordinate of C was. Well, I know it's in line vertically with the B, so it has to still, it's Y. And I know that it is in line horizontally with the A, so it has to still, it's X. So the coordinates of C are x2, x sub 2, y sub 1. Okay, to find the distance of AC, remember we're going to look at the two verticals, so we would just subtract y2 minus y sub 1. And to look at the distance of BC, we know that vertically it's the same, so we're looking at the horizontal difference, that is x2 minus x sub 1. Then we would use Pythagorean theorem to find the distance. And again, we would take our short leg, I don't even know if it's our short leg, but one of our legs, x2 minus x sub 1, and our long leg, y2 minus y sub 1. And we're going to square those distances. So we get x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared equals the hypotenuse squared. And then if we want to solve for the hypotenuse, we just have to undo that square. So then we get the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared equals the hypotenuse. Okay, that looks complicated, but if you just remember it is Pythagorean theorem, that makes it so much more simple. Okay, so here they're just showing us the distance formula. You need to memorize it, but remember, it's really not that hard. It's just Pythagorean theorem. So that's something that we want to memorize. That was a very bad start. Let me try again. Okay, so here, now when I'm doing this, I think of a right triangle. I don't always draw a right triangle, but I'm thinking of a right triangle. So I have to think about the horizontal distance. It went from 3 to 6, so it's going over 3. And the vertical distance went from 5 to 9. So I know this is going up 4. So then I'm just doing my Pythagorean theorem. 3 squared plus 4 squared has to equal AB squared. So we have 9 plus 16 equals AB squared. So 25 equals AB squared. I take the square root and I get that AB is equal to 5. Okay, so next one, I'm looking at the horizontal distance. I'm thinking, how far is it from -1 to 3? It's a distance of 4. And then I look at my vertical distance. How far is it from 4 to 8? It's also a distance of 4. So I use my Pythagorean theorem. 4 squared plus 4 squared equals RS squared. So I get 16 plus 16 equals RS squared. So I get 32 equals RS squared. So then I know that RS is equal to the square root of 32. And then it said in simplest radical form. So I know that 32 is 16 times 2. So I'm going to get 4 square roots of 2. Okay, I want you to try number 6, 7, 8, and 9, and then we'll check our work. Go ahead and try. Okay, check your answers. Number 6, you should have got 2 square roots of 17. Number 7, you should have got ST equals the square root of 29. Number 8, you should have got PQ equals the square root of 2. And number 9, you should have got AB equals 10/3. So pay attention. It doesn't matter about your distance. Distance is always positive. So it doesn't matter if when we subtract and we get a negative or a positive. When we square it, it's going to become a positive. When I have fractions over here on number 9, I want to make sure that I write the difference in improper, because you want to square an improper fraction. You can't have a mixed fraction and then square it. That's not going to work. And then again, I got common denominators. Both of them happen to be perfect squares, so it was pretty easy to take the square root. All right, number 10. When finding the distance between 2 points, does it matter which ordered pair is first when using the distance formula? Absolutely not. If I have the point 2, 3, and whatever, 4, 5, when I subtract 2 minus 4, I would get -2. And if I subtract 4 minus 2, I would get +2. Same thing on the 3. When I went with the 3 and 5, I went 3 minus 5, I would get -2. And if I went 5 minus 3, I would get +2. We don't really care because we're going to go and square it. So if I do -2 squared plus -2 squared, I'm going to get the exact same thing as if I do 2 squared plus 2 squared. Because we're taking it to an even power, it doesn't matter if our difference is negative or positive. So it doesn't matter which you use as the first point or the second point. As long as you just stay consistent to form a good habit, you will be absolutely fine. Number 11. A triangle has vertices at 2, 3, 4, 8, and 6, 3. Draw this triangle on the coordinate plane. Find the perimeter of the triangle, round your answer to the nearest 10. All right, when I draw, I like to label. So I put my point 2, 3 and give it a label. 2, 3. And then I'm going to put the point 4, 8. 3, 4, 5, 6, 7, 8. And give it a label. 4, 8. And I'm going to put the point 6, 3. And give it a label. Okay, and then I remember that perimeter means distance around the shape. Well, the base is easy because it's horizontal. So I'm just going, how far is it from 2 to 6? It is 4. And I pay attention to what kind of triangle I have to make my life easier. I see that this is going over 2 and up 5, and this one's going down 5 over 2. So I know that I'm dealing with an isosceles triangle. So I really just have to find one of those sides. That's going to make my life a lot easier. So here I pay attention. It's going over 2 and up 5. So then I think 2 squared plus 5 squared. That's 4 plus 25. So this is the square root of 29. And it's isosceles. So the other one is also the square root of 29. So for my perimeter, I've got to add my sides. I have 4 plus 2 square root of 29. Because I had square root of 29 and a square root of 29. And then it says round to the nearest 10th. No problem. 4 plus, I find the square root of 29 and multiply by 2. I get about 10.77. I always do my work one more decimal out than where I need to round, so I don't get rounding errors during my work. So then I get 14.77. I've got to round that to the nearest 10th, so 14.8. Again, we talked about it. It was an isosceles triangle because 2 sides were congruent. You need to be able to spell isosceles correctly. And if we want to get technical, if we wanted to do by angles, I can see that it's acute. Just a little review. You didn't have to write acute though, because that's not what I asked you. Okay, next it's telling us to find the area of the triangle. Well, I have to remember the formula. If I don't remember the formula, that's a problem. So I know that the area of a triangle is base times height divided by 2, or 1/2 base times height. And on this triangle, the base is 4. And the height is the 5. Remember, the height is not necessarily always one of the sides. So here we get that the area is 10 units squared. I don't know if it's centimeters or inches or what, so we just put 10 units squared. Okay, I want you to pause the video. I want you to try number 12, and then come back and we will talk about number 12. Okay, so this one has a lot of different answers that you can put. First of all, I think, hey, if the distance is 5, then the distance squared has to be 25. So then I just have to think about numbers that add to 25. So 9 plus 16 is 25. That would be 3 squared plus 4 squared equals 5 squared. So I know that, that's not a very good 5 right there. I can use the points 3, 4 or 4, 3. Or I can pick a different 2 numbers that add to 25. So I picked 5 plus 20 is 25. That's the square root of 5 squared plus the square root of 20 squared. That's square root of 5. Square root of 20 is 2 square roots of 5. So I can have square root of 5, 2 square roots of 5, or 2 square roots of 5, square root of 5. There's a lot of different combinations you can get to 25. But different answers would work.